So far we have discovered that there are lot of parameters that are attached with your process, and their uh, their values are very important, as your process is need to be run at a steady state, or maybe you are running with the batch unit. Okay, so for batch, again, you need to maintain a level of your vessel, and that required certain pressure and temperature requirement as well. So the determination of the position of an existent interface between two medium, again, these media is usually fluid, but they may be solid or combined form of solid and a fluid, because like if you are in flour mill, so certainly after the crushing of the grain, the vessels are filled up with the solid materials, but the main transportation of this that solid flour from one part to another part need to be done with the help of air. So they both becomes a combination of solid and gas. There you need to maintain the level of solid particles. So again, there are level uh, transmitter and gauges need to be installed in a respective vessel in order to understand how much capacity you have in your process. Many techniques are available for the measurement, and which we will discuss precisely at for the application wise. We need to categorize our sensors and gauges. Okay, so all have different advantages as well, and certainly they have certain limitations as well. Like if we are dealing certain most of the level transmitters widely used for liquid, but certainly they cannot work with the solid level uh, level transmitters, because they give a lot of errors if you install in a attached with the equipment which are dealing with the solid material. So again, the theme is quite simple, as we had discovered in when we are learning about the temperature transmitters and gauges, that you need to optimize the sensors gauges according to your process, and certainly the cost is also influence a lot, because when you are talking about the accuracy and the sensitivity of any transmitter or gauge, so definitely the cost become much higher. So with your own budget, you need to optimize at which sensor is best, and this is the very important factor you need to know. Another factor is that when you are controlling a food processing, so it's important for a food engineer to understand the working principle of any transmitter or sensor, because sometimes the process, there are certain trouble comes with the time, but only these are the transmitters, these are the gauges through which you need to assess your process, and it is not every time that your transmitter and sensors work properly. Sometimes your process does not able to, you could not able to run that your process according to your spec, just because your transmitters giving you a lot of error. Their readings are deviating with their original value. So again, you need to understand the whole theme of your process, and as I have at the beginning of my lectures, I have told you that these uh, sensors are installed in a series in a pattern, and you need to understand your process theme accordingly. That if the tank is has a temperature of 90 degrees centigrade and you are running that fluid in a from raw material to your process area, so certainly if your flow meter deviate uh, and does not give you the reading of the flow rate, and there the temperature transmitter which is installed in the line start to rise up and coming nearer to 90 degrees centigrade, what is the storage time material temperature is. So that means you need to identify that, okay, that your flow meter is now deviating and does not giving you the correct reading. So in that way, all these transmitters, pressure transmitter, level transmitters, are interconnected in your process, and these are considered as the eyes of a food engineer. So their working principle, their errors margins, like if I have installed a transmitter which is very expensive and which has a very low error percent, so you definitely rely on that transmitter a lot as compared to a transmitter which is installed which has greater margin of error. So in that way, you need to optimize your process. Okay. It should be emphasized from the start that there is probably no one best method or a specific rule to follow for the selection of measuring devices. Material presented here can be definitely will I have included a lot of transmitters and gauges, and maybe when you pass out from this university, because research is going on, and as you know that new products are coming and their demands are rising. So when a product developed, a new product developed, and the process you are going to design that, so maybe the available transmitter will be not very much accurate for them. So there again, this is not the fixed my only what I'm exactly want to convey you is that whatever you are stating here is a very general knowledge. Okay. So these are apparently used in any part of the industry, like if food industry as well. But if you go in the chemical industry or in a mechanical industry like power plant or coal-based power plant, so these transmitter you will find there as well. But the matter is that the power generation units are so far quite similar, but now you can see the solar panel are developed by a lot of industries. So you know they are installing new processes. So for that they need to design new transmitters as well in order to assess their process accurately. So my exactly means that if you are using a certain transmitter, level transmitter for a edible oil refinery, and you are using that similar transmitter for a ketchup manufacturing company, so there mm, there is a margin that the performance of both transmitter vary because of the different dealing of the material at different companies. So every time the development in this area is keep going on, and when definitely you go in the industry, so you need to be uh, keep in touch with the upgradation of on this field as well. Okay, because different times you will get different availability of the sensors in the market. Now these are some of the pictures, and or I have explained you because it is very important to understand that how much this transmitter is important for you to understand. Like this, the first one, if we see here, this is the figure of a boiler, okay, which is half filled, and you can see this is the level transmitter attached with this, uh, and we are assessing the level in that way that it is half filled properly. uh, and if I want to know that how much water is available in that vessel, or if I'm interested to do the mass balance across this unit, so certainly what is the inlet stream, I need to install the flow meter over there as well. But at what is on the downstream, certainly for, the steam is manufacturing in this unit. So the producer uh, steam which is coming out from this steam boiler has a flow rate as well, so I need to install a flow rate over there as well. But if, let's suppose this unit is running with the time, okay, and if I am coming after 2 days and watching this process, so how can I comes to know that this is the mass which is accumulated in this vessel? So the only way is that certainly there are some temperature and pressure transmitter also need to be attached with this equipment. Ultimately the level transmitter is giving me some idea about how much capacity of the liquid is available in this equipment, because if I know the inner diameter of this cylindrical equipment, and the length of this equipment, complete length, okay, so if level transmitter is 40%, so I can easily understand that 40% of this volume of this boiler is contained water. On the other hand, the steam has a filled with over the 60% of the volume of the vessel. And similarly, if the level of water is higher or lower, I can easily assess that. Okay, if you know the temperature of the liquid water, you can easily know what is the density of that liquid, okay. You have the data available in your book as well, or even online as well. uh, so you can easily understand how much capacity, I mean in ton or maybe in kg, that the liquid water is available in this equipment. On the other hand, if I know the temperature and pressure of the vessel, I can and if I know what is the volume of which is occupied by the steam, so I can easily calculate first by with the help of temperature and pressure value what is the density of this the steam present. If you know, we had studied the formula for the density of gases in if we know the temperature and pressure by using general energy equation formula. So once you know the density, and once you know the occupied volume of this by the steam in this equipment, so you can easily calculate the accumulated mass of the steam present in this equipment. So in that way you can easily calculate the accumulation mass. It's a very simple way I have explained you, but when you go in the industry, it is not only that you are dealing with the water. So certainly in, let's suppose in the edible oil refinery, you are importing the crude oil, or you are you are purchasing the crude oil, maybe in your country premises. So when you purchase a particular batch, okay, in a certain quantity, and you start to run your process, if you have studied in edible oil refinery, different oils have different behaviors. Even different oils have different densities as well, and their behavior to the process is quite different. So if you run the so companies edible oil, sorry for more including of the this type of information, because once you run a particular batch which you had purchased in bulk, okay, so you run your process complete and just finish that particular batch, okay, and then flush out the remaining part present in the process, okay, then clean up your process, and after that you will connect it with another purchased second type of crude oil, and then run with the same process. So sometimes it's happened and you are making the your production sheet, that how much raw material is consumed and how much material you have produced. So at the beginning there is a huge deviation come due to the accumulation of the mass. So the only method to understand and to rectify that how much mass is accumulated in your process is you need to know all the specs of your equipment, their diameters, their heights, their complete specs, okay. After that you need to know these type of running parameters like temperature, pressure and level transmitters, the flow meters, okay. So in a vessel you can easily calculate the accumulation mass, what I had explained for the steam boiler. Well, this is a second one is a typical type of figure which is representing the reactor, okay. And certainly if you are there are three types of reactors like batch reactor, plug flow reactor, and CSTR, continuous stirred tank reactor. So here I'm talking about two reactors, batch reactor and continuous stirred tank reactor. The batch reactor certainly requires certain that you need to fill up to certain height, okay, which means that required certain capacity of your raw material, which may be 2 or maybe 3 or maybe only 1. So again there are certain accumulation and which may deviate with the temperature, because certain in some of the reactor there are open vent to the air as well. So when you increase the temperature, the vapors get wipe up from the process. Again, it's a matter of fact that the vapor pressure increases with the temperature, but on the other hand you are wasting your material in the environment, and how much you are wasting out your environment, and which type of material you are wasting out in the environment. So again, it's important to understand the whole chemistry of the process, how many types of components or how many compounds you are including in this process, and what are their behaviors with the temperature and pressures, okay. So again that's why these types of process are very important to understand. Here this is the figure of a distillation unit, and you can clearly see at the bottom there are certain level which is maintained within this complete distillation column. On the other hand, we have certain level in accumulation tank. Well, in a reboiler or in a condenser, there is no such type of level as such maintained, or you may say that the level transmitter usage abundantly used, because they are most oftenly installed in such a manner that if the overhead vapors move directly to the condenser where they condensed out, okay. And most of the time these type of accumulator tank or reflux drums are installed just below the condenser, so all the liquids are fell down in these accumulator tank, so there is no requirement to install level transmitter in condenser. But sometime in a reboiler, there are numerous types of reboiler, in fact, like thermosiphon or kettle reboiler, which I hope you will study in heat and mass transfer. So in specifically kettle type heat reboiler, you need to maintain a level over there. Then this is a very simple example of illustration about how you need to monitor the level in a storage tank. Again, if I will talk about the storage area side, so company has a very defined area to maintain their stocks, either in the raw material, if I will talk about, or either I will talk about for the product point of view as well. So there are specified tanks, okay, for raw materials, and there are specified tanks for finished product, or there are specified tanks available for if any byproduct you are receiving with your process, okay. So it's not something like that that if you are using a tank for a raw material and you will after an year you are putting your final product on that particular on the same tank. So all the tanks need to be specified, because whatever type of material they are dealing, accordingly their material of construction will be identical with the with your raw material or with your product which you are placing on that tank. So again, the level are very important to monitor, and again I will say there is not we will monitor in that way like you have installed a transmitter and just left that once. So they need there are in a single tank, if I will talk about, there is a electrical device which we so called as a level transmitter is installed in the tank, okay. The level gauge installed on the tank, and in every 4 hours or in every 8 hours the operator need to go to the tank and monitor the level by using dip tape, or there are other methods, okay. So this is very important to cross check your process every now and then by utilizing these type of different level transmitter gauges in order to assure that your process is running with accurate numbers. And why it is so important? Because if you are consuming your raw material and if your level transmitter deviate and you are only rely on that transmitter, what happen after some times the cavitation occurs in your process, and which may disturb your process badly. In fact, if again I will give you a very good example about edible oil refinery, where all the process at certain part run under vacuum, and once the air come enter to this part of the vacuum, the temperature increase dramatically, and which may cause internal combustion as well within your process, which may damage your packing or inner part of the process. So on the other hand, if your process deviate with your required parameters, so again your product deviate with your specs. And vice versa, if you are putting your I mean final product to your tank, and you are only relying on a single level transmitter, what happened if that final product will increase and increase in such a manner that the tanks overflowed, so certainly this will cost you a very high, because you know for producing your final product, there are a lot of things need to be take account, like you are preheating that, then you are preparing it by removing the moisture, purifying your raw material, and then you are introducing that raw material into your reactor, and then that produces converted into your final product, and then if you waste that final product in such a manner that your tank is simply overflowed, so it's a big blunder, I think, for by a food engineer. So when you are enter in the industry, you something like that, if you are sitting in a car, so you need to take your eyes around in such a manner that you know every part of the road where all the traffic is going on. And certainly if I will compare the traffic in Karachi, so it may be possible that you may stop your car and somebody come and hit your car even as well. So it is important to cross check your process by using numerous these type of transmitters and gauges. Again, it's very important. So level gauges and transmitters, I believe that introductory part I have explained a lot, but if I'm broadly classified them, so there are two methods. One is direct method and the second one is inferred method. So the direct method is something which we are directly calculating the height of particular liquid in a vessel or in a equipment. But on the other hand, like if I will give you the example of temperature, so there are temperature sensing devices as well which are directly calculating the temperature. On the other hand, we had studied some of the temperature transmitter which are converting their temperature into the pressure, and then that pressure value will be transmitted to your control room in order to assess that how much temperature is going on in your process. So this is inferred measurement, in fact, because you are measuring something else, but you are getting the result something else, which is the level of your process. Similarly here, we also know that from this formula P is equals to rho g h, which we had studied a lot in fluid mechanics, that the pressure of the liquid column directly influenced with the height and does not include any impact of the diameter. So similarly, that theme can be used, that if you are using the pressure measuring devices, and that value can be inferred into liquid. So this is the second method, which is so called as the inferred method. So if I will talk about the direct method, so first come the visual measurement. Okay, and visual measurement simply that you install certain instrument in which you can visually watch the level of your liquid, uh, or the solids, maybe coming from certain part to your equipment. So for these purpose, uh, there are certain thing as well, like they are accurate, reliable, uh, and but they have certain limitations. So and on the other hand, they cannot be transmit your you know visual measurement to one part of the process to another. Like if you have installed a visual transmitter, so it's not something like that value can be transmit from process area to your control room. So this is some of the drawbacks. But again, if I have which I have previously emphasized, that you need to cross check your process. So if you have installed a transmitter even in the within the equipment, but there are certain side glasses need to be installed in order to watch visually that your equipment is filled up to that mark. So there are maybe more than three, but they are generally three. Like one is dipstick level measurement, a steel, tape, and bob, and side glasses. Dipstick, uh, lead lines, steel tapes with bob weights. Dipstick and steel tape with bobs are abundantly used in food industry. So I just explain you with the help of figure. Dipstick level measurements are most oftenly be done only for open tanks. Okay, so there are still what happened. The tank is open, and you have a steel rod. Okay, and that rod has certain calibration what similarly you have in your scales, like in most of the time you are using the rulers for making the diagrams. But that steel rod is much higher in the size, but again it has certain limitations, because you need to put that one into this liquid and then remove it to use to another part. So again, it's old traditional method of measurement of the level transmitter, and most of the time it is used in order to calculate uh, the tanks which are open and present in the storage area, not in your process area. But maybe there are some times you need to install slope tanks. Okay, slope tanks are the tanks, like if you start up your process. Okay, uh, in every part of your process, you the first step to maintain the levels of your process, and then you turn on your heatings, like by you with the help of steam, or with the help of thermic liquids, which most of the times used in order to provide uh, transport heat from one part to another part. Okay, so you know at the very beginning part of your process, what happened, all the materials need to be moved down into the slope tank, because you cannot mix it with your raw material as well, because that directly might change the aspects of the raw material even as well. uh, on the other hand, there are certain methods that you need to insert the off spec material with your raw material with minimum amount, 2 to 3%, not more than that at all. So again, for a startup, and similarly for shutdowns, there are tanks which normally named as the slope tanks, and most of the time they are placed in the premises of the your processing unit. So they are not very huge in capacity, so, and they are open as well, so you can use these type of tape, I mean steel rods, in order to calculate its level manually, in fact. But again, it's dangerous if you are dealing the liquid which is coming with a higher temperature, so ultimately it has certain limitations. On the other hand, if we will talk about a steel tape and bob, so it's a steel tape, and this bob weight is attached at the end of this tape, okay. And once you left that tape, what happened, this due to this weight, uh, and you are standing at the top of the tank, and this bob weight move in that down and down due to this weight, and submerge in the liquid as well even. And once it touch this bottom part, touch with the tank bottom, so there you just take back this whole tape. So what happened, how much tape is submerged into the liquid, you take the reading of that, and you can easily assess that what is the level of this transmitter. So these two, even in present scenarios in Pakistan, uh, these manual measurements are still going on in food industry. Well, very oftenly steel tape and bob weights are abundantly used in Pakistan, and even throughout other country as well. Okay. Then we have side glasses, level gauges, and these are in fact not for the storage tanks. These are, again, sometimes we install this type of level gauges for our uh, slope tanks as well, even in our final finish accumulator tank, which I have told you, like reflex drum, where the top products is accumulating. So similarly, you can if you have a certain storage tank or accumulation tank for your product, or maybe for your waste material, so for that you can use these side glasses in order to visualize that what are the level percentage of these vessels. So they are open. So for open, you don't need to again reconnect it with the vessel again. Okay, so this tube is open, and with that we have a scale which is calibrated accordingly. So there you can easily assess what is the height covered by the liquid. On the other hand, if I will talk about the closed tank, so for closed tank, what happened, either it is under pressurized maybe, or maybe under vacuum. In both scenario you will get different results, because if the process here is under vacuum, and that part you have just left open to the atmosphere, so again this value will deviate a lot, because here the pressure will be much higher. On the other hand, is the inner part of the air, I mean where the vacant part, the pressure is much lower. So you know, it will show less reading of the liquid as compared to what the actual reading of the tank is present within, or the actual level up to which the material is filled up in the equipment. So if the pressure is atmosphere, so you can use this type of level side glass. Or if uh, you have a closed tank where the pressure does not matches with your atmospheric pressure, so again certainly it's required to reconnect it with your vessel. There are other side glass as well. Okay, so far we have covered dipstick, lead lines, and steel tape with bob weights. Steel tape with bob weight, and the second one is side glass level gauges. So I'm just giving you certain information related to these type of manual, or you may say that visual gauges or method of measurements of the level. But there are certain errors, there are certain I mean in problems that might be you need to consider while you are adopting any type of methods of measurement in any of these. So first of all, if I'm just going to talk about dipsticks and what are the problems associated with this type of measuring method, is that there is a steel rod, okay, available, and which is calibrated either in the fits or either in the inches or maybe in the meters formation. Uh, but you know, the operator need to dip it in the tank, okay, and then he have to take out from that tank in order to understand at how much level, like if the operator dip that rod into this tank, what happened when this rod come out, certainly some part of the rod get wets up, okay, and you can easily as it is measured calibrated as well, so you can easily comes to know that what is the height of this uh, tank up to which the material is filled in this tank. But again, the main problem here is that the tank should be open, because you need to insert that tank and then you need to take out that rod from the tank. And as we know that this rod cannot be so huge, so definitely this method is only can be used where the tank size is not good, and that means that a small tank size, it is only applicable for a small tank size. You cannot use it for a 20-foot height or 20 meters height tanks. Although if you will go in the industry, there are very huge height and diameter wise tanks are available to store your raw material as well, on the other hand to store the final product as well. The second method is lead line. So here what happened, the material is filled up, on the other hand there are certain lines which is painted by the lead color, okay, and you can easily by standing at certain part of the tank, you can easily watch that up to that much level your tank is filled up, okay. Again, for this type of tank, the tank should be open. Normally, if you have visited any type of dams or like huge river reservoir, So this method is used on that case. Although in industry I unable to see this type of storage tank where we use lead lines in order to measure the level of the tank. Okay. Although this is a method through which we can measure the height of any reservoir or any storage, okay, which maybe you have kept for raw material or for final product. Okay. Then the most abundantly used method through which we manually calculate uh, the height of the tank is steel table with bob weights. Why I'm saying that? Because this type of method is only used for a small tank. On the other hand, these method can be used for either for a small tank as well, and on the other hand it can be used for closed tanks as well, which is partially open from certain part. Well, if I'm talking about the storage, so storage required certain specifications as well, because your product maybe if it interact with the normal air, uh, it may deviate its storing specs. On the other hand, the there are a lot of dust materials is present in our environment, and if we storing our whole material in open tank, so what happened, they may fell down in this tank, and certainly what you have produced a very refined product, which again becomes but does not match your required product specifications, or again you need to do certain operation in order to remove the dust particle from what you have stored in open tanks. So most of the time the tanks used in our industry are manufactured in such a manner they are cylindrical. On the other hand, they have certain type of roof as well, okay, which is open but has this shape, okay. From this part it is open, which makes sure that not a lot of air enter to this part. On the other hand, certainly if you are pouring your final product at 90 degrees centigrade, okay, and it's just come into your storage tank, so certainly a lot of vapor will evacuate from this part, or maybe due to this saffron formation, they may again condensed out. So this opening forbid the dust particle to enter in this tank, and if the tank get pressurized, so the inner part air can be easily be removed from upper part of this tank. There are a lot of other method as well. Okay, so here you will provide a small hole, so there from there an operator can insert this dip tape, which can be rotatable. Like if you can see here the picture, this tape is completely rolled up, and when you lose it up, so it may fit and go due to this bob weight down and down until it's reached the bottom part of the tank. So again, the method is quite simple. You will lose this weight, bob weight at the bottom part, and then you will re-roll it, and then just note it down when this part will move upward. So what happened? It will be, this tape will be definitely calibrated with certain unit of the length, and you can easily assess that okay, that much height is present in this storage tank. Okay, certain things can happen, like if you have poured a very viscous liquid. So which may accumulate in this part in such a manner that this bob cannot move below this mud type of materials or viscous type of material. So what happened? Your again level reading will be not accurate. That means the greater material is available on in the tank, although you are measuring the wrong length of the material because the bob tape will give you the wrong reading. Another method is that if you just move your bob weight in such a manner that it simply touches the surface of the liquid, so you can easily come to know that what is this length, okay, and if you know the total length of the tank, you can easily come to know that how much length available in the tank. So there are two methods. One is in which you will touch the bottom part of the tank, okay, which is actually the real method of dipping operation. And there is another method which I have just showed you, that the bob weight need to touch the upper surface of the tank, okay. So you just need to take the height of here from this part, or it can also be done in such a manner that you submerge that weight, okay, and you note down that much part is submerged into the liquid. On the other hand, this is the reading of the tank. So from there you can easily determine this height, which is so called as the LH dip method. So these are the two methods you can use. But here, if the liquid get very viscous, your reading might be deviate. Most of the time what happened, we used to recirculate our tank for a while, okay, so that it's homogenized throughout it, okay, and your measuring method will become so accurate because the denser material does not settle down and does not solidify itself at the bottom part of the tank. Well, that's it. So these are the three methods. On the other next part, we have studied the side glass level gauges, which there are two are explained here. On the other hand, one is more which I have seen more oftenly in the industry, like you see here in the mixing tank, which need to be run in a batch wise. So you may install a glass. You don't need to attach a whole tube with this, okay. Like if you attach the whole tube, definitely will have to attach in that way. So you know this tube is very sensitive, does not bear a lot of pressure. On the other hand, if you will just place a glass level gauge, which is maybe you can manufacture by up to the specified demand, with the increasing in the thickness and increase your mechanical properties that can bear higher pressure even. I'm able to get its picture in Google at all, so that's why I'm representing here. So you just need to attach this in this level part, and what you have to do, you need to insert your raw material up to that much height, And as we know that your batch need to be run, your tank need to be runs in a batch process. So in batch process, first what happened, you insert all raw material, and then you start mixing or reaction or whatever, operation will go on. On the other hand, continuous stir tank reactor is something in which continuously raw materials is coming. On the other hand, it is producing certain amount of the product. So there you need to install certainly a level transmitter as well. But for field reading or for visual assessment that up to that much height the tank is filled up, you may insert or place a glass level gauge over here. The main advantage of this type of glass level gauge is that they can bear up higher pressure, they can bear up higher temperature, they can bear if the process run under vacuum even. Okay, so which is not the case if I will talk about previously, which I have explained you in the slides. So this can be also be used in accumulator tanks as well, or reflux drum, or there are abundantly used as well by visualizing the flow as well. If certain fluid is moving from one part to another part, so if you insert these side glass on that line, so you can easily comes to know that okay, that much. You cannot assess or you cannot get the actual value of the flow rate, but on the other hand, but you just assess your process that this stream is active and fluid is flowing uh, from this part to another part. Then we have another type of side glasses level gauge, and this type of level gauge, as you can see here in this figure, has a very particular height or length through which you can visualize, or you can easily visualize that up to that much mark the material is filled up in this in a particular accumulation tank. Well, if I will talk about the main application of this type of level gauge, most often, I mean, in the boilers, they are abundantly used in every industry, uh, where the water level need to be critically watched every now and then. That is, its level should not be becomes higher than 50% of the vessel of the boiler. So there as well, the level transmitter is also installed on the boiler, but on the other hand, for visualizing the actual value level uh, of the liquid, we also installed side glasses level gauge uh, of this type of level glass. One of the very important application of this level gauge, as you can see here, this is not up to in the way that you have to fill a batch up to a particular mark. So there is a wide range over which you can easily visualize that up to that much level the tank is filled. So sometimes, like in so many food industries, like in edible oil refinery or ghee producing companies, they use thermic fluids in order to transport heat from one part to another part. So what happened, uh, the thermic oil is filled in a particular tank, okay, which contains definitely up to very bottom mark of the level. On the other hand, then they are move towards furnace side, where the heat is added to the fluid. Okay, and then the provided heat is used in order to transfer heat, certain amount of heat from the thermic coil to your maybe upcoming raw material or finished product, in order to you know uh, meet out your process specifications. So what happened, due to, as you will fill the thermic coil at the very beginning of the process, so it will have a temperature of 30 to 35 degrees centigrade. On the other hand, if your process requirement is that uh, your reactor need to be run around 200 to 300 degrees Celsius, so accordingly you need to heat up this fluid up to that much mark. So while you are heating as much higher temperature, what happened, the liquid start to expand. Definitely its density becomes lower, as we know that density is the function of temperature. So there is a huge drastic change in the temperature, so due to which, if you filled up your system and this accumulator tank up to 1 to 2 volts, so maybe possible at the running temperature, your this accumulation tank will showing the level up to a very higher mark. So this is the main use of this type of level transmitter. uh, on the other hand, this type of level gauge, uh, we normally uh, calculate or give the reading in the form of bolts. If you can see here, this is bolt uh, 0, then 1, 2, 3, 4. This is not something like you I mean level transmitter will not give you in certain distance wise height. So it this visual glass is just to visualize the level, and normally we calculate it by with the help of bolts. This is the main diagrams. Okay, this is the front view, this is the side view, and on the other hand this is the top view. So you can clearly see here, this is a very thick glass installed at this part of your uh, of level gauge. And then we have a special metallic column where uh, the I mean the liquid allowed to move upward in this direction, as there are 2 points which are interconnected with the vessel. Okay, so liquid will start to fill up and will confine this part of the column. Okay, on the other hand, this is the special glass which is installed at this part. On the other hand, these are the bolt uh, which are through which we have tightened our this whole assembly. So this is a very simple level gauge type. All these so far we have covered are used for visualizing the level in and tank. Now we are moving towards automatic tank gauge. So I will definitely start to explain the figure. First, there are two types. One is chain float gauge, and the second one is closed tank operation of float uh, cable and weights. So what happened in if you can see here in the first one, is the method is quite simple, that it has a floating element or a round ball which could not be sink into the liquid. Okay. uh, well but uh, there is a circular calibrated scale as well, uh, around which the pointer will move and displays and give you the reading accordingly. So let's suppose the tank is quite empty at the beginning part. So what happened, this floating element has a position at the very bottom part of the tank. As this floating element move downwards, ultimately the pointer attached with this pulley will move anti-clockwise and will display you the reading present at this part of the calibration scale. So after some time, certainly when the liquid start to filled up in the tank, and uh, due to the buoyancy force, liquid won't allow this floating element to sink into the liquid. So this floating element remains its position at the surface of the liquid and move upward as the level rises in the tank. With the rise in the floating head, what happened, the pointer start to move in a clockwise direction and will give you or reflect you the reading accordingly with the calibration. The similar technique has been used for in the closed tank operation, and I must say I just want to add here is that this type of level automatic tank gauge abundantly used, and I believe that present in every liquid handling companies, because these are very simple operation and give you a very precise reading even if calibration can be done so accurately. So what happened, again, this type of gauge has a floating element uh, which is present at this part. Okay. And the chain is also attached with this floating element, and after there are pulleys attached at this end and this end again. But after that, there is a pointer which moves upward or downward accordingly as this floating element moves upward or downward with respect to that how much material is filled up in the tank. This is a very simple example of a liquid which we need to run in a circuit. So at the beginning part, I'm talking about the thermic fluid. Okay, in most of the food industry, we normally use therminol 55, 60, or 65 fluids in order to transport heat from one part to another part of your process. Well, steam is also used for this purpose, but for steam we have a very different scenario. Okay, so let's start with how you start up your process. Okay, your process demand of temperature is around 200 to 300 degrees centigrade, and at the beginning, definitely when you are introducing this fluid into this tank and throughout through complete process. Okay, so its temperature is around 30 to 35 degrees centigrade, which we consider the normal conditions of Karachi. So when you introduce this fluid in this tank, from this tank it will cover up the whole circuit volume of your process even as well, and the furnace where this fluid is going to get certain amount of heat, and which heat is demanded from for your process. So let's suppose you have filled up your fluid throughout your circuit as well and in the tank as well up to that much height. But after sometimes, once you start heating in your furnace, that means you're providing heat
through the combustion of natural gas and with the help of introducing the oxygen. So this flame will directly heat up the fluid which is moving in your complete circuit. Okay, it's a closed circuit of the fluid. So this pump is simply pumping up the fluid from the accumulator tank to the whole circuit and returning back it to your original tank position. So gradually it will start to increase your fluid temperature and ultimately increase your process temperature demand as well. So let's suppose you reach your required temperatures specifications of the process, which is around 200 degrees centigrade to 300 degrees centigrade, and here you can clearly know that there is a huge difference between 30 to 35 degrees centigrade, and once the process fully run to your demand and specifications, which has a temperature requirement of 200 to 300 degrees centigrade. So in between of this level, you have not introduced an extra liquid or fluid in your process, but its volume increases. Why? Because temperature is directly decrease the density of this fluid. Okay, and that means once the temperature rises, the same amount will get greater volume. So on the other hand, maybe possible you will reach that level of the liquid. So these type of level gauges are used in order to just to monitor any certain level in your accumulation tank. Okay, you are not so much concerned about this level. I mean, because its level should be not so much below as much that it will cavitate your pump. Okay, if the amount totally emptied here, so ultimately what happened, this pump get cavitated, and the whole process becomes very much badly affected by this operation. But on the other hand, if you will say that its volume is increased into that much height that your last bolt is still dip on that tank, so ultimately it means that it can overflow your tank. Why? Because certain change in the temperature may occur that may cause an increment in your volume of the liquid which is present in the whole circuit. So there is a wide range between the whole level which you are measuring in bolts. Okay, with like bolt number 1, 2, 3, 4, 5, 6, or maybe more than that. But ultimately there is a wide range, and you are not precisely concerned about that, that your level should be meet on that part that directly impact your process conditions. So that's why we use this type of level gauge to visualize only that what's going on in your whole circuit. These are also used in order to visualize the level of the condensate tank as well, because when you provide heat to your process, in response of that the latent heat is transferred to your process. Okay, in saturated steam. Okay, that sensible heat is utilized in order to increase the temperature demand of your process, and ultimately the steam get condensed into liquid form, and then the condensed liquid is transported to a condensate tank. Okay, because you don't need to so much treat that water, because that water is considered as the most purified water, because it's distilled water. In fact, it does not contain any amount of oxygen or any other traces of any salts or carbonates or bicarbonates, which you will consider as the impurities present in the water. So in the condensate tank, you may install this type of level gauge to visualize that you are not precisely concerned about that that level should be maintained on your condensate tank, because from condensate tank the water need to be add up in your boiler. Okay,
but you are directly putting some treated water as well in your boiler as well, but this is the additional water you need to feed, and there is no requirement of any pre-treatment as well to before feeding it to boiler. Then we have automatic tank gauge. I believe I have explained this in previously. So there are certain parts of automatic tank gauge, and this type of tank is abundantly used in the industry. I believe has a wide range. I believe like if you will go in the food industry where they are dealing with the liquids, they use this type of automatic tank gauges. If you are dealing like if you are going to see the how the petroleum sector tanks, so again you will find this type of tank gauges available widely there as well in order to monitor the level of any tank. And a part of that, like food industry, edible oil refinery, or liquid processing industry like milk as well, milk processing industry, dairy industry. So you will find this type of level gauges abundantly over there in every storage tank because of their simplicity of the working and precise working. This tank gauges can be converted into transmitters as well. This is the very fine, very good, you may say, advantage of using this type of automatic tank gauges. You just need to add this smart displacer and attach it with a digital component. We just need to get the information about how this tank pointer is moving. Okay, you need to attach this smart displacer with this pointer. Once this pointer move downward or upward, in response of that you have attached a digital device with this which is calibrated accordingly. Okay, and that may transfer this signal into electrical signal and transmit it to your control room, and you can by setting control room you can easily assess what is the level going on in a particular tanks where you have pouring your final product, or you're taking the raw material from a particular tank. So this is again a very effective thing, but certain things you need to understand because this floating element is attached with a chain and the pulley, and that pulley is attached with another pulley. Okay, and this is run in a whole single chain, and this chain certainly when the tank gets empty, ultimately this floating element move towards the bottom part of your tank, and once you start to running down your final product into this tank, so when it's enter into the tank, certainly it will shower from this part of your tank. Okay, so certain part of the liquid will come in the contact of this floating element as well, and the upper part of the chain as well. If you periodically does not remove or clean your chain, so ultimately this deposited element, deposited material which deposit due to the running down or entering of the material in your tank will move towards this pulley, or maybe in the second pulley, which may corrode your pulleys, or that may stuck your this whole gauge working. So in response of that, ultimately you will get the wrong reading. You will, if you have attached the transmitter as well, you will get the wrong readings as well, because the displacer is again attached with this pointer, and once it the whole this assembly get stuck due to uncleanliness of your chain, so ultimately what happened, your rating will come wrong. And so it's important to periodically, month wise or maybe sometime week wise, it depends upon your material you are dealing with. Okay, if it is a very viscous liquid, so you need to frequently clean your chain every now and then, uh, okay, with the running of your unit. So these are some of the component which I had discussed. Okay, precisely they have explained that which type of materials are normally used, and like for food stuff you need to consider uh, the material of construction like a stainless steel of 316 grade, which is very expensive material. mm, and so you need to clean up your whole chain as well, and ultimately the floating element as well, periodically or annually. So it's make sure that your whole tanks are precisely, this gauge is precisely giving you the results. So there are certain steps through which you may install your automatic tank gauge, and it's a simple procedure which I have listed all step by step. The main working principle I believe you have understand properly. So if you will go through this, you can easily understand that what is the basic procedure, like and steps through which you can install this type of gauge in a tank. Then we have magnetic tape float device. This is again a very abundantly used type of level measuring device, and this is not only attached in any storage tank, it's also attached in numerous process as well. Like I have abundantly see the usage of or installed this type of level devices in CSTR, in fact. And you may use them in like where your final product accumulated in your process area, or any running accumulation tank as well, where you are feeding, or maybe at the bottom part of the distillation unit, because they are also works give you a very precise reading as well. So there is the main working phenomena of this magnetic tape floating device. Like this is a device, okay, and you can see which is present at the outer part of this cylinder, okay, and this floating element is a magnetic floating element, and once the level is high, get higher and higher with the time, what happened, this outer part will move upward, and ultimately this inner magnetic part will move accordingly how this floating outer magnetic part move upward or maybe on the downward direction, which totally depends upon the level of the liquid. So what happened, you have attached certain assemblies which is also attached with certain calibrated scale, and with the movement of this dip, or you may say that the non-magnetic dip tape, so you can easily assess about how much level will increases or may decreases accordingly. You may attach it with the electrical signal as well, and there are two methods. You may attach with the a mechanical device as well in order to convert it into the gauge formation. Okay, and you may attach it with the digital device in order to convert it into uh, I mean gauge transmitter. Here I have more precisely explained about the magnetic type float device. Okay, these are the certain components inner okay, this is they have explained zoom wise about how the internal floating element is move upward and downward within this whole assembly. So this is the main floating element, the movement of inner magnet is totally depends upon how this outer magnet or floating element moves. Okay, this is simply the stamp and this is the stopper. It is very important that you should know what is the range of your process according to which you have installed within a particular process. As I have explained you at the beginning of my lecture, that just like in a distillation unit, this is not like that you have attached the whole LT in complete column. You just need to precisely understand that what is the range up to which you need to fill this vessel. Similar scenario you have with the reactor sometimes. Okay, there are certain specification of the reactor, like if you are running the CSTR reaction in a CSTR reactor. So there is a precise range, or maybe the range is around 80% or maybe around 25% of the tank you need to fill in order to run your process properly. So it's totally depend upon the process. So we are here. This is simply rising floating ball to correct the reading switch. Okay, let's suppose you have installed a permanent magnet over here, and it is attached with this floating ball. Okay, once you can clearly see this element is above than this level, so that means it is normally open. Once you can clearly see here the level is get lower, and this magnet is completely come near to this, so it will get close your liquid once the level get up to that much level. So they can use vice versa. It's depend upon whether your stream is getting out or your stream getting into the vessel. It's totally depend on that usage. Okay. Then we have variable displacement measuring device.